let me just introduce Dr. Reinaldo Valenzuela. He's a member of National Academy of Engineering, a fellow of IEEE. He has also won many IEEE awards, including Eric Sumner Award, Bell Labs Fellow, WWRF Fellow, 2014 IEEE CTTC's Technical Achievement Award, VTS 7 Grade Award. University of Chile has a PhD from Imperial College, the Director of Communication Theory Department, DMTS at Bell Labs. He has been engaged in many research like propagation measurements, MIMO space-time, HETNets. Got about 200 publications, 44 patents to his credit. Got about 33,000 Google Scholar citation and highly cited author in Thomson ISI and Fulbright's senior specialist. We are very fortunate to have you. And thank you for driving all the way from New Jersey. And I think with that, let me stop sharing. I'd like to welcome Dr. Valenzuela. All right.
Okay, please let me, because I tend to get carried away with all the fun and the excitement. Excellent. So welcome back. I hope you guys are not too tired, and I'll try to wake you up a little bit if I can. I know it's hard. I mean, we've done 3G, 4G, 5G. Maybe the youngest of you don't remember 3G, but I was around. And well, now we are going towards 6G. So I'll try to make it inspiring and thought-provoking as we go from 5G to 6G. In fact, it's already been very, very interesting. One of our speakers earlier on had very interesting questions about the dollars per gigabyte and things of that nature. And it seems that we are insatiable in our will to consume more and more gigabytes for either the same or less dollars. So, and yet the industry continues to march along. And so I'm sure we're going from 5G to 6G thanks to the unstoppable developments of technology. So, road to 6G. So we did do a little bit of what you call it, crowdsourcing, and we did some surveys internal. After all, we have some close to 100,000 people. And so we asked, what do you think are the main technology aspects that, or defining applications of the 6G era? Now, it seems that there is an evolving consensus. The name keeps changing, but not too long ago, we called it immersive experience, AR, VR, XR. Maybe today, and we'll get a little more into that, you can call it Metaverse. But definitely, one aspect of that is this fusion of the cyber-physical realities. And then, of course, in parallel, a very strong trend that we see happening, even surprising most of us, is autonomous transportation, autonomous trucks, vehicles, buses, etc. And then perhaps enveloping all of this is the amazing changes with artificial intelligence and software that can act as our agent, cobots, and help facilitate numerous activities, as we would get onto. What would be the technologies that tend to support this type of applications? Then, of course, artificial intelligence is way up at the top. And you can be skeptic, and I used to say, it's neither artificial nor intelligent, because when you have to pay all this, and forgive the term, but I think they're called digital assistants, let's call it that. There are people who are paid, fraction of a cent to actually tag data. I started with tagging animals. And the only way you can do artificial intelligence animal recognition is if you started off with tag database. Well, who did the tagging? Well, it wasn't artificial at all. It was actually very, very sentient humans that did the tagging. And without the tag database, there is no artificial intelligence. So it was neither artificial nor intelligent. It was rather dumb and very human at that. So anyways, enough of skeptics. Having said that, when you actually see it in operation, it's just mind-blowing. I mean, it started off with being the best chess player, and now we have incredible applications. So artificial intelligence, no doubt, comes at number one. And then, of course, cloud-native architectures. We see how more and more you used to be able to do, whether you want it or not,
I was trying to save my Amtrak ticket onto my local store in my cell phone, just to be sure in case there was no network. Well, it turned out that the latest version, I won't say who the vendor is, of my mail client would refuse to allow me to download a copy of the document to my local storage because absolutely wants to keep it in their own cloud. Okay, thank you very much. What if I have no network? So I think this little capsule captures the ambivalence we have between the future where everything is cloud, and then at the same time, the insecurity that coverage is not guaranteed. Batteries are not guaranteed. And so what if you find yourself without battery in your cell phone or without coverage? And now the omnipresent mail server software company decided that that document can only be accessed if you can access the cloud. Well, sorry, you don't travel today, or you have to pay extra at your on board. So cloud native, very attractive, but I think at the same time it underlines that we have a long road to go. I mean, we are here talking about 6G and petabytes, and this morning we couldn't even hear the audio from the internet. Okay, it was all the world around and from China, and it's pretty amazing, but nonetheless, long way to go before we can really trust this new world. So I'll keep doing this back and forth between being outbounded, optimistic, and visionary, and then at the same time trying to challenge ourselves that we have a lot of work to do before we get there. But anyways, satellite, that's another one. Satellite, of course, and this is unbelievable now how we are shooting up tens of thousands. Any one LEO, MEO, LEO is shooting tens of thousands of satellites. I don't know what's going to go on with astronomical observations because all this garbage up there, it must be a bit of a difficulty. And they keep coming down, so you need to keep shooting them up. Now, not long ago, if you were around, there was another round of this called Iridium. Now, Iridium also thought they're going to beat the telcos with satellite-based coverage because they could cover huge expanses where there's no coverage. Well, hello there, there's no coverage there because there is no revenue there because there is no people there. So Iridium went up and crashed down in total collapse of business case, only to be rescued by being bought by defense contractors and defense establishment that, of course, they have their own reasons to have guaranteed coverage wherever they want to go. So are we going to have the same scenario now? Of course, reusable launchers are dropping dramatically the cost of launching the satellites. But are we really going to have a business case for all these low orbit satellites? In fact, I was just reading one that can maybe break the mold because it's satellite to a regular cell phone. So you don't have to buy a separate handset. You don't have to, really have the expense of the old-fashioned launching. So maybe the combination of reusable launchers and talking to unmodified cell phones, it's going to be the paradigm change, and we're going to have a real competition to, land-based base stations. But remains to be seen. But nonetheless, in every 6G talk, non-terrestrial networks also shows up. And of course, new spectrum. We cannot do wireless without going into some new spectrum. But as you know, as you go up in frequency, the propagation losses get higher and higher. So we go from 20 miles rural base stations range to a kilometer to today in dense areas is 100 meters, intersite distance to 100 meters. So it's pretty dense. We'll get to that into that some more later. But still, new spectrum is unavoidable because it's the currency that allows the wireless networks to work, of course. But I touched upon already, what are the dangers or what important characteristics? Security comes up number one. I mean, if you're going to let the software and the network do the driving for you, you better be very, very confident that this is all secure and safe. Latency and reliability go hand in hand. Definitely reliability and security, they kind of go together. Energy efficiency is coming up fast as a very important new KPI, as every month we read a new events regarding sustainability, climate change, etc. And then, interesting enough, there seems to be a consensus that the old driver from 3G to 4G, 4G to 5G, which just about pushing throughput and capacity, well, maybe it's not the number one anymore. It is high up, regardless, but maybe there are other important aspects of the network that we need to worry about. So, in Nokia Bell Labs, we believe very strongly that there is these three domains: the digital world, software-driven, cloud, resident, the physical world, of course, that we're all familiar with, and the human world of social interactions, social networks, etc. And there is an incredible opportunity for the fusion of these environments or these domains. So I think you're already familiar. You heard other talks this morning about digital twins. So it's kind of interesting. Again, let's switch from being hype-driven to realistically based. We used to call them simulations, but now we call them digital twins. That's fine. The simulations have gotten so realistic that we invented a new name and we call them digital twins. Why the new name? Because the simulations are so good in some cases, so realistic that you appear to be in some kind of digital or sort of twin universe or metaverse sometimes. It's got to be created, got to be given to the world of video games. I mean, if you guys track that, I don't personally, but as an outsider, if you've ever seen a recent video game, the realism is just mind-blowing. And of course, then out of that comes this digital twin concept, where as if you were playing in a video game, the idea is that you could be exploring, say, a factory floor. And before you make the expense of installing everything, you can play a simulation game. And you can move around the factory floor and see how it fits, how it works, how it can perform as you need for your manufacturing or whatever floor it is, without spending, well, I was going to say spending a dime, but then again, all those software coders are going to be, want to be paid salary, but of course, it would be a fraction, and the risk involved and the dangers involved would be non-existent compared to building a whole factory before you know if it really works for you. So digital twins is a really amazing opportunity, and it's happening in front of us. Factories, we are in New Jersey, we have a collaboration with AeroFarms, where we actually have production of vegetables in a vertical fashion. And then we've collaborated on some sailing all around the world in this combination of cyber and real worlds. So driving up to the metaverse, of course. So this explosive growth of a concept that perhaps didn't even come to mind just a short few years ago, it's now dominating the imagination of many, many people. In fact, as you know, some very large company decided to change their name, and perhaps it's a copyright infringement, but Metaverse has become a goal, a vision, and something a lot to be said about. Now, do I see myself going around the streets with these goggles and escaping into some metaverse? Not really. But then, have you seen the latest versions? It's not the ugly goggles anymore, but what if it just looks like sunshades that just happen to have heads-up displays on it? Well, maybe now you're talking. So it varies. So don't say it's not going to happen, because I was on a call and I was saying, you guys are crazy. This is never going to happen with people going around. Enough already. I mean, I sit around my kids and everybody's in their cell phones out and not talking to each other. You want more of that. But then again, while I was on the call, as most of us do, and you're in your Zoom session, it was getting a little boring. So I then do a quick Google search, and I found there are 2 billion video game players today. And then I stopped. I said, it's it. That's it. It's going to happen. You know, whatever you can charge, $1 per 2 billion is $2 billion. So, so it's a huge opportunity, no doubt about it. It's unstoppable, and it's just a matter of numbers. If there is 2 billion video game players, this is 2 billion potential subscribers to whatever it is that you're peddling, that are high income, they have a massively powerful computer, and they have massive high quality display. Wow, this is a sweet spot market, addressable market to be addressing. So yeah, metaverse. And then once you have that base to pay for the expense of the developing the hardware and the software and the terminals, all sort of new applications are going to happen. You're going to want to do a trial run, as I was saying, of perhaps hostile environments using metaverse. You're going to do certainly a repair of critical equipment in the metaverse first before you go into the real world. Can you imagine doing a metaverse surgery in your digital twin of a corpse or a human before you try your hands in a real person? And so I think there is almost no end to the kind of things that we can imagine that take advantage of this metaverse and the digital physical fusion. And so there is another aspect that we find very strong in this view, is that it's not just about you in your living room or even the employee in their workspace with the connected to the virtual world, but we say a person moving naturally about anywhere, in the street, in the park, hiking, and then able, together with the terminals, but network, a very strong network, low latency, high bandwidth, ubiquitous coverage. That's where we believe you start getting very interesting opportunities. And so I think I've already gave you a little bit of a prequel of the digital twins and manufacturing environment. But here you have sort of an animation of what can happen. You are moving inside the world, and there is a robot, large, dangerous machine moving at high speed, and maybe there is a human that is encroaching into a danger zone. So you get alarm, alarm. Something's going to happen here. So that's just one example in the factory floor. Now we also have digital twins of a topic dear to my heart, which is propagation. So in the not too recent past, not too distant past, we used to do propagation almost blind, just treating it like you put an antenna and you try to illuminate best you can, and you make your predictions, your calculations, back of the envelope. You say, oh, it gets out to 40 meters, 70 meters, 80 meters, whatever. Then, it comes antenna arrays and beamforming, but this is so far from the real world of propagation, where life is much, much more complicated. But now we can do predictions using ray tracing and other tools that get us closer to the real propagation, and where we can do joint optimization of site siting and rate, latency, etc. So, as rounding things up, what are the technologies that we expect are going to rule this new world of 6G? New spectrum, as I said, is the currency of wireless. We'll have artificial intelligence, and there is a complete new field that talks about artificial intelligence native air interface. Again, you can be a little skeptic and you can say, hey, well, wait a second. I did my COM information theory work, and I know that if you do QAM of a high density, it's approaching Gaussian constellation or Gaussian signaling. And if you do some of the advanced maximum likelihood sequence estimator receivers, you are capacity achieving. So nothing you can throw at me can do better than that, artificial intelligence or not. And you're absolutely correct, except that you miss one big factor, channel estimation. In that Shannon world, it assumes a whole bunch of things being ideal. And then when you are in the real world, you need to deal with impairments, let alone things like computational complexity, which don't even come into the world of Shannon, or power consumption. So once you start optimizing into this multidimensional space, you find that tools like artificial intelligence can indeed provide a great advantage in your toolkit. Network as a sensor, I think other speakers have spoken at length, but believe me, another pillar of 6G is joint communications and sensing. Extreme connectivity and specialized architectures, and without forgetting security and trust, which it keeps coming around as a recurrent factor. Now, of course, cloud is going to be very important, And it's not just a cloud, but multiple clouds. People, some speaker earlier on even talked about the cloud within my own phone. That sounds like a very small cloud, but nonetheless, you can see we talk about a heterogeneous form of cloud, from the very large public cloud to many intermediate levels. So the fabric, of course, on the network is what keeps everything going. So it's very important. Will continue to include optical, of course. There is, we heard very interestingly how the cost of delivering to the home over a fiber is 20 times less than over wireless. So again, let's be careful here when we get all excited about being wireless masters of the universe, and we want to deliver fixed wireless broadband access. Yeah, as long as it doesn't take anything away from your mobile revenue, which is 20 times per megabyte more profitable. So that's all fine. If you have spare capacity, you can serve the fixed wireless. But I don't see anytime soon that service providers are going to be sacrificing that 20x revenue to provide broadband access to fixed homes. So optical to the home is king. Optical coax. I mean, the hybrid networks have proven to be extremely optimized, where you get fiber to the curb and then coax to the home. That's really a good combination and hard to beat with wireless. Now, wireless is fantastic when, of course, many cases there is no fiber or the home is too remote to dig a fiber all the way to the farm. Then wireless can do great things. So optical will remain there. Microwave, of course, and then new forms of business, wholesale business, MVNOs, etc. So all of this has to happen, as we call it, frictionless, optimized, and moving nicely. So I talked a little bit about the introduction of artificial intelligence. This is going to be happening in stages. So this is the classical OSI model. We deal with every function separately, we optimize, and then we put it together. It has worked very well. We have now transmitter receivers. We know how to do them. They're predictable. They're incredibly complex systems, and yet they work to spec, which is amazing. We did that by divide and conquer. Now we are moving into a new paradigm, which is we're saying, well, okay, each one of these things, we can put some machine learning on them. And we already get some advantages, yes, modest, but we do get advantages. They tend to be in things like computational load or power consumption. Of course, not in throughput, because as I said before, we're close to the optimum or capacity limit, so it's hard to improve on that. But the computational load and power consumption are different stories. But then we can start doing things together that in the past were too complex to try to optimize together. Now, of course, in the beautiful world of machine learning, it doesn't matter. You just throw everything into the black box, shake it up with all of the data training you can master in the world, and pops out a better solution. Now, don't ask me why or how, but it works. So don't argue with success. And the more you do it and include a larger and larger set of questions or set of aspects of your system, the more advantages you get. So that's what we call a artificial intelligent native design for 5G and 6G. So we already see some advantages, and I mentioned one of the issues, we call it the deep receiver. One of the issues that it's a hard one is channel estimation. Some of you that are familiar with MIMO and multiple antennas, then it's not just one-to-one channel you need to estimate before you can communicate, but it becomes end transmitters times end receiver channel pairs or channel matrix that you need, and in broadband case, per tone of your OFDM frame. So now you have a huge amount of channel coefficients to estimate. It's becoming overwhelming, and we solve through pilots. Yes, but then we're consuming more and more of that valuable throughput in sending pilots so that we can do the channel estimation. When it turns out that machine learning can do all of that and can do it better than we know how to do it through pilots and conventional estimation methods. And we already have results in that domain. Now, Constellation Design has been something that pretty much stayed the same for the last decade or so after QAM. Now it turned out that we can, using machine learning, do constellations that are optimized per each level of signal-to-noise ratio and gain us some highly valuable dBs in the process. Now, then it gets really exciting, but really mind-boggling when you revisit the Shannon, and Shannon used to say, the semantic part is no interest to engineers. Yes, at the time he was only interested in communicating bits. But now with all these new technologies driven by artificial intelligence, it becomes possible to start doubling into the semantics aspects. So let's not get too abstract. For instance, you are in a Zoom conversation. We already have the tools where if you happen to be in a new crowd and you don't know the people, you could have artificial intelligence running simultaneously and telling you the names and positions and interests of each one of the individuals in the meeting. Now, of course, immediately, yes, I agree. Security, privacy concerns are huge. But given the right context and given the right protections, this can be invaluable. You are in a meeting, you don't know half of the people, you get to the bubble saying this is VP of research, this is VP of sales. Very good. This person is based in Shanghai, and right now time over there is 8 in the evening, while this other person is based in New York, and it's 6 in the morning. So you can be aware of semantic concepts that are available to you through machine learning, artificial intelligence, that certainly cannot be captured on the bits and the bytes going over the link. And of course, with the help of machine learning. So there is a lot of exciting stuff going, and this is close to my heart, on the microwaves and the quantum computing. Of course, there is dedicated talks close to, the distributed massive MIMO is already one of the established pillars that is going to be happening on the 6G, already in 5G, but very strong in 6G. Let me just tell you one interesting aspect. Of course, it becomes obvious that the cell concept is outmoded, it's passé, antiquated. It makes a lot of sense to realize that when a cell phone is trying to communicate, it's not just one serving base station that is within range that can capture the signal. There may be several other ones. So far, we treated that, oh, that's interference. So we're going to do something. We're going to put coding on top, or we're going to do frequency planning in the old days. Or today, we just treat it as interference. Well, why should it be interference? It's valuable signal. It's just happening to show up in a different base station. So why couldn't the signals from all the base stations that are within radio range of that user process that simultaneously and get an even more reliable detection? Absolutely can. And as you say, well, but that's going to get very complicated as you move. Yeah, well, same with the neighbor lists. As you move around, the set of base stations that may be serving a particular user is going to have to be dynamic, and it's going to have to be per user. So per every user, you keep a list. This user is being received by stations I to J. And as you move around, now it's K to L. That's fine. We call that distributed massive MIMO or cell-free MIMO. And so the cellular world is going to sell less, believe it or not. And I think that's the right way to go. So because at that point, there's no more interference in the system. Every signal is a valuable signal if you process jointly at the right time. And of course, you can do the same in downlink. I am running out of time, but believe me, the spectrum in the range of 140 gigahertz and higher is being investigated intensely, as it provides incredible opportunities in terms of bandwidth, absolutely, but with its own challenges in terms of range. But as we discussed before, there's going to be so many applications that tend to be indoors. In fact, there is a secret that it's not discussed in polite company, which is 80% of the data traffic in mobile networks happens to be to users that are indoors, either inside their office or in homes or in other dwellings. So why do we call it mobile radio anymore? At best, it's pedestrian radio. But anyways, at those indoor environments, short range is king. So then the reluctance to move up in frequency maybe is outsized and can be handled. So anyway, rounding up, we see this merging of the digital world, the physical world, and the human world as perhaps the strongest of the new dimensions in 6G. And with that, I think I'm done. Happy to answer any questions.
Question from the audience? Okay, we have two questions. So you can keep there. I can give it to John.
Hello. Hi, Reinaldo. Great talk. Oh, should I go ahead? Go ahead. So you mentioned AI/ML on the PHY, and you seem to allude that energy efficiency is one of the benefits, and it's a bit counterintuitive, at least for me. I would think that it's the reverse, because GPUs today, tensor processing units, they're very power hungry. Compare that to ASICs and accelerators in a general purpose processor. So yes, maybe if you can shed some light on that, because that was counterintuitive.
Very, very, very good question. Thank you for that. And I was speaking in high-level terms, and the notion really was that if you look at the Shannon frame of mind, then energy efficiency doesn't even belong in that space. Now, it is true that if you put a machine learning or a convolutional neural network inside the receiver, initially, especially if you implement it in general purpose computing, it may be 100 times more power hungry. But these are the early days. What I'm also trying to say is that if I now introduce the concept of energy efficiency in a...
Could you grab a microphone? In front of the microphone.
Oh, yeah, sorry. Well, what I was alluding was I can now, in the ML frame of mind, introduce energy as part of my variables, which the Shannon world does not even include it. But your point is very valid. I may achieve some algorithm in principle more efficient than some other baseline, but then I need to go to the implementation, and of course I'm going to have to go to FPGAs or perhaps even custom ASICs before I realize any real gains in power consumption compared to the existing baseline. But very good question.
Okay, I have two questions. First one is Nokia Bell Labs published a while ago a book called The Future X Network. And I'm just curious, how does the architecture for 6G differ from anything that was in that book? And then the second question is related to your channel estimation discussion, which is fascinating. Do you see in the current 5G networks, we have the L2 scheduler and the DU, we've got the RIC, and the RIC has some AI/ML adjunct processing for the scheduler. Do you see in 6G, based on not having, using AI/ML to synthesize the most optimal modulation and coding scheme, let's say, and channel estimation for a given channel condition? Do you see AI/ML actually being able to adapt to real-time channel conditions better, right, by having those two functions merged in some way?
This is all happening very, very fast as we speak. And so the first wave, I say, has been to try and learn, can we do any better than we have done so far using conventional comp theory, optimization algorithms, scheduling algorithms? And now the answer is clearly yes. In individual modules, separated silos. Now we're starting to be more ambitious and putting them together. Now you're asking even beyond, can you do scheduling and modulation and coding perhaps in a single super complex ML? Maybe one day. I think we have ways to go before we get there. I think we really need to secure some strong wins. Right now, the improvements we see with ML are modest, but they're pointing in a direction that it was unthinkable only a couple of years ago, where you can now introduce in the same frame of mind of optimization angles that before were completely orthogonal. So the potential is huge, but we're at the very beginnings.
So, Reinaldo, there's a question from the online. You mentioned cell-less. Do you foresee a base station-less future too, or is it what you meant?
No, I don't. I absolutely don't. And this points to two aspects. First of all, It's like saying, can you have wireless without radios? I mean, I don't know. I cannot process the question. So, but it points to something more interesting, which is the notion that we can go smaller and smaller cell. So it's not new. It's been around since 3G. So we could go to sort of like the ultimate small $10 base station, call it access point, and you put it everywhere, and the density is super high. So dividing by 0 gives you amazing numbers, large numbers. We know that. So if you take capacity C0, whatever it is, and divided by 0 area, your throughput per area, it goes to infinity. No question about it, in principle. But we also heard the speaker this morning that said, no matter what you attach to somebody's wall, one nail, $500 a month. Yeah, that's rental. And the owner of that wall that is allowing you to nail this antenna to it knows that the traffic you're carrying is generating billions of revenue. Yeah. So it's not going to let you do that. So one point of fact, and back to your question, the densification of network has stopped dead in its track at about around 200 intersite distance. And the CTO from AT&T here can confirm, but even in Manhattan, Times Square, they will play with whatever new technology you bring to offer them, as long as in existing sites. Yep. Number 2 mantra, existing sites, because the reality of it is any smaller than that, and it becomes exponentially more expensive to deal with permits, with power, with backhaul, et cetera, et cetera. So how could we have, let's not say baseless networks, but even the concept of hyperdensity, it's already questionable because of reality.
This is the last question, a very brief answer I can give. In addition to comm sensing convergence, but what about actuation like haptics, realistic closed loop interaction between humans and digital and physical worlds?
Yeah, I think that it's going to happen. It's not really the domain of this conference, but I think I have connections in the biological world, and there is another emerging, which is cyber biology, cyber, medical. It's happening very fast. Whether you're talking about exoskeletons or you're talking about connectivity to nerve endings. So that's happening very fast. And if you put the two together, then I think we have the potential for amazing actuators, sensors that bridge this gap between the physical, human, and the wireless world. Thank you.